So now that we know some new theorems involving angles, we can now apply that, since notice this proof is all dealing with angles. So let's think about what they're giving us and where we're going. We might even label in the picture. So it says given angle 1 and angle 2 are right angles. Now, how do I show angles are right angles in a picture?
In a picture, that's when we put the little box or in the corner, or the little square, however you want to refer to that.
Angle 1, angle 2 are right angles, and we also know angle 1 is congruent to angle 3.
Oh, well, if I know that angle 1 had the little box, could I just put the box around angle 3?
What would be your reason? How would you be able to do that?
Well, I know that all right angles are congruent.
Okay.
But I guess I haven't stated
said that yet.
Okay. So let's maybe just put the little tick marks then.
Okay, so
but I know where we're going now.
Is congruent to angle 3, which, again, guys, we're not trying to trick you. Hopefully you're seeing, okay, that would make sense that where we're going here. Mm-hmm. So, again, we can't just go ahead and say, all right, well, let's put 2 in for angle 1 here and call it good.
So if I had a statement that said angle 2 and angle 3 were right angles, then I could go straight to saying that they're congruent because of the right angle congruence theorem. But because that's not the statement that we have to start with, that's not what I can go with. Okay, but I do know that if angle 1 and angle 2 are right angles, I can now state that angle 1 and angle 2 are congruent.
Now, why can't we just go straight here? Why? Before we would say angle 1 is 90 degrees, their measure, and angle 2's measure is 90 degrees. What allows us to go straight to here?
That's the right angle congruence theorem. That's the shortcut that we learned that was
so
really
we can say right angle congruence theorem. Or if you forget the name, you could say what Ms. Hope Graby just said. All right angles are congruent. So we can say angle 1 and angle 2 are congruent. So
okay. Ooh, now we can. I'm seeing some transitive now because we have an angle 1 and both, because we've used the first part of the given, but we haven't used the second part yet. But there's an angle 1 there, and there's an angle 2 in step 2. So because angle 2 and angle 3 are congruent to the same thing, they're congruent to each other. Yep. That's the transitive property.
And so angle 2 and angle 3 are congruent to angle 1. We can say they're congruent to each other, and transitive works again for congruence and equality with angles as well as segments. And
I couldn't have used substitution. No. Substitution is only for equality.
No. And notice again, this theorem allows us to bypass saying they're equal to 90, their measures are equal. It allows us to go straight here.
Love it. Love those theorems. This next one, we are given a couple of supplementary statements.
Ooh.
Okay, I'm hoping you guys are, or I'm hoping at least Ms. Palermo is thinking what I'm thinking. We know that the measure of angle 3 is 40. So I'm going to go up here and just the measure of angle 3, we know that that's 40. I'm going to mark that in my picture because they give it to us. And we know that angle 1 and angle 2 are supplementary, which I can't really mark that in my picture, but keep that statement in mind. And angle 2 and angle 3 are supplementary.
All right, so while you're writing that, I notice where I'm going. I'm trying to show angle 1 is 40 degrees, which to me that seems kind of logical with the stuff. But what's kind of a red flag to me is in the given, and Ms. Hograby mentioned this, the fact is that they were given 2 sets of supplementary angles. Anytime I'm given 2 sets of supplementary angles, I'm going to be thinking that maybe that congruent supplements theorem. Now, I notice in those 2 sets that there is the same angle, angle 2. So if 2 angles are supplementary to the same angle, I can say that they're supplementary to each other.
Does it make it supplementary to each other? Let's think about it for a second. Because if I say that angle 1 and angle 2, I'm sorry, 1 and 2 together add to equal 180, and 2 and 3 together add to equal 180. Do you think that 1 and 3 are going to be supplementary with each other?
No.
But keep in mind the name, the congruent supplements theorem. So we need to use the idea of congruence.
Because here's the reason why I was thinking that, because I see angle 1 is supplementary to angle 2 is supplementary to angle 3. So saying angle 1 and 3 are supplementary, like transitive, right? But Transitive only
Doesn't
works for
work.
congruence and
Does not
equality.
work in a statement.
All
And
right.
I'll tell you guys that is probably one of the most common mistakes that we see.
Yes.
And that's why Mrs. Palermo is playing that devil's advocate there.
All right, so I know angle 1 and angle 3 are going to be congruent to each other because they're both supplementing the same angle, and so they got to be congruent because of the congruent supplements theorem.
All right. And again, just to re-emphasize, if you have two angles that are supplementary to the same angle, so 1 and 3 are both supplementary to angle 2, that makes these 1 and 3 congruent to each other. Okay.
So then I noticed the given has something about equality and the proof has something about equality, and I just stated something about congruence.
So we've really just used one step of our given, okay?
So I'm thinking I probably want to switch the congruence to equality. So I can use the other part of the given. So I can say angle 1's measure is equal to angle 2's, or angle 3, sorry. Angle 3's measure because of the definition of congruence.
Perfect. And I love how you said that you noticed that the other statement is an equality, and you can't change the measure of or angle 3 to be congruent to 40 because 40 is a measure. So that's got to be a measure. Okay, so now we've used this step also.
So what I'm thinking now, and I see exactly what I'm going to do. I know that I can replace that 40 degrees and for angle 3 and say angle 1 is equal to 40 because I could say substitution because technically I can replace 40 in for angle 3, but I also noticed that transitive could work because since angle 1 and 40 both equal angle 3, we can set them equal to each other.
Exactly. And you could use either one. It really won't matter. If it's equality, they're a little bit more flexible than obviously when we get into congruence.
Now, this is one, again, we've seen one before today with no picture. So can't really use the picture to label, which is not necessarily a bad thing. That just means that we're restricted to just what's given to us. So I'm going to start writing this down.
And keep in mind, we could draw a picture if you wanted to.
If you had to. But a lot of times they leave, when there's no picture, that means it's doable without, for sure.
Yeah.
So I'm going to write down all the given stuff.
All
and
right.
while I'm writing it, I want you to think about anything that you're noticing.
Oh, I do notice something. I noticed that we have two complementary statements. And so I might be thinking right now, or I am thinking right now, maybe we'll be able to use that congruent complements theorem.
And again, what gives that away is that they're two sets of complementary angles. Now, are you noticing anything that they, like, do they have the same angle like the last one that we did?
Yeah, they don't have an angle in common. And I don't have a statement that says that there's two of those angles that are congruent to each other already. But I do notice that we've got something about 1 and 3, and I can tell that 1 and 3 are going to end up being congruent.
And why are they going to end up being congruent?
Because they have the same measure.
So can I just go ahead and say angle 1 is congruent to angle 3?
Well, no, because I'm trying to think what the reason would be. I know that if I had measure of angle 1 equal to measure of angle 3, I could turn them into that congruent statement.
And
I can do that
We
first.
could do that. And the reason why is the fact that they both equal the same measure. All right, so I can say angle or measure of angle 1 is equal to measure of angle 3. And what would you like to say for a reason?
Well, I like to use transitive for that one, but substitution would work also because we're inequality.
Okay, so transitive or substitution would work. All right. So now we've used this part of the given. And again, what Mrs. Hochgraby's thinking, she's noticing two sets of complementary angles. In the two sets, there's not the same angle, but she is noticing that angle 1 and angle 3, now we know they're equal.
So, and if they're equal, then they're congruent.
Which means they're congruent.
So, yeah, and to use the congruent complements or congruent supplements theorem, if they don't have a same angle in common, we have to have that they're congruent, not equal. So we do need to restate that.
All right, what's the reason for saying they're congruent?
That's the definition of congruence.
So we've used, let's backtrack. We've used these part of the given. We've used this. Now we have this, and we have that we have to work with.
Okay. So now I have my two sets of complementary statements. I also have two angles within there that are now congruent to each other. So now I can use the congruent complements theorem.
And again, since we have the congruent angles here, and angle 2 and angle 4 are both congruent to complementary to congruent angles, then we can say...
And it's not that they're complementary. I'll tell you, congruent supplements and congruent complement
know.
theorems never prove complementary or supplementary. They prove congruent. So I know that the other two angles, angle 2 and angle 4, must be congruent.
And that's because of...
The congruent complements theorem. And that's what I was supposed to prove. And I even have them in the right order. How about that?
Awesome.